right, so we're on.
Hello, everybody. If you are just coming into our Big Systems Nexa 3D webinar, we're going to get started in just a moment. We're going to give people just another minute or two, and then one of our co-hosts, Andy DeHart, is going to pull up the presentation too, in conjunction with getting started. And just as soon as the presentation comes up, I'll start my remarks. Hello, everybody. I'm Joe Jones. I'm the owner of Big Systems, and thank you for tuning in today to learn more about our newest edition, the Nexa 3D printer. Andy, if you could hit the next slide, please. I'm going to introduce everybody in just a moment. I wanted to run through the agenda. So we're going to be talking to you for about 30 minutes, and we're going to leave plenty of time for Q&A as part of the webinar. I just have a few comments, and then I'm going to turn it over to our partners at Nexa 3D. Next slide, Andy. I'll start with some introductions. I'm Joe Jones. I'm the owner of Big Systems here in Menomonee Falls. I'm joined on the call by Ashley Mistry. Ashley is our 3D sales lead, and she is in our conference room today with John Peterman. John is our VP of Sales and Marketing. And then also joining me on the call from California at Nexa headquarters is Michaeli Markison, Chief Revenue and Growth Officer. And then based out of Wisconsin, is another one of our Nexa 3D partners, Andy DeHart, who is the Channel and Product Development Manager. Next slide. Just a quick overview of Big Systems and who we are, and many of you may know this, but we are located here in Wisconsin in Menomonee Falls. We're a 27-year-old company. We have been selling 3D equipment for 7 years. In addition to our wide format business, we have sales offices here, demonstration facilities, and as you see in the lower left-hand corner, a shot of our warehouse. We stock all of the consumable materials here for the equipment that we sell. Next slide. Next slide, please. So we really like to think of ourselves as your local experts and your local resources. Obviously, we have the content experts on the call today from Nexa 3D. But we really do our best to understand and become experts in the technology so that we can give you the local support, starting with your evaluation of the equipment, installation, operation of the equipment, backup support with all of your consumable needs, and then all of the aftercare that you might need as you operate your system through the years. We do not take a one-size-fits-all approach, but rather we really try and work with you to understand your needs, your applications, and recommend the best fit for you. Next slide, please. Now I'm going to turn it over to Michaeli Markison, who's going to start with the introduction of Nexa 3D.
Hello, everybody, and thanks for joining us. Next slide, Andy. I would like to start talking a little bit about Nexa 3D and who we are, basically, as Joe correctly did. Next slide. We come from a long journey. The old company was born from an idea in Rome, Italy, 3.5 years ago, where basically three inventors decided to try to do the fastest possible DLP system. Then eventually ended up meeting with Avi Reichenthal, who's our CEO, and we'll speak about him in a minute. And then right now we're a fully established company in Ventura, California, counting over 30 people in research and development, manufacturing, logistics, service support, customer care, and sales. Next. I would like to spend a moment to talk about our leadership team. Our CEO and co-founder is Avi Reichenthal. Is an expert in additive manufacturing and in our business. He has been for 12 years a CEO of 3D Systems. Our COO is Isar Medalsi, who's a world-renowned optical and material scientist. And he has been working on top of Bruker, ATH, and Wyatt. He's been a pilot for the Israeli Air Force. Here's Michele Markesen, that I believe you start learning. I basically built 3D Systems global reseller network, and I've been with 3D Systems for over 12 years, and then I've been with XYZ Printer for printing for 2 years. I was Chief Revenue Officer at 3D Systems and Senior Vice President for 3D printing for XYZ. Andrea Tanaro and Luciano Tringali are two other co-founders. Luciano is an experienced engineer and is the person responsible for engineering here at Nexa. Andrea, one of the co-founder, is one of the world's leading digital strategists. He has founded a couple of companies, and he has recently sold Doing to Capgemini. On top of that, we have Itai Barel, who's Director of Software and Data Science. He's also an AI scientist, which is very well versed in artificial intelligence, and he has been fundamental to create all our software. This is basically to say that we're not a startup, like somebody's started into somebody's garage, but we're a fully established company with a proven track record and extensive experience and expertise in operation, optics, chemistry, machine vision, apply IA, and additive manufacturing. Next, I will now let Andy drive that. Again, thanks for participating. It's an honor to be here, and it's an honor being talking to you. And thanks, Joe and the team, for allowing us to do that. Andy?
Very good. Well, we'll jump right in with a few of the product and material specs and do our best to paint a picture as to what this new offering has that's fresh in the market space. A few of you on the line, if you follow 3D printing closely or been involved in rapid prototyping through either AMUG or other associations, might have seen the equipment and the logo advertised at least once before. Current show environments over the last 90 days, as we all know, is limited those opportunities. But I had my particular first view of this prior to joining the company recently at the AMUG 2019, when it was previewed here in the States for the first time in Texas. There was an earlier launch for the international teams, of course, toward close of year at Formex. One of the most well-attended booths at that show, and there was a very strong reaction to the release at price point and performance when that curtain was pulled back. Essentially, it's about the technology. So I've been in this business for a little over 2 decades, working for a variety of the OEMs in the distribution component of this also. And photopolymers is not necessarily brand new to the arena of 3D printing, but how this new organization that Avi, Michele, and others have put together at Nexa really puts a fresh twist on things. So without getting into too much of the detail, but you're taking an hour of your morning to do just that, to take a little bit of a peek under the covers, as it were, as to how this technology works. I'll start at the top and then reverse and come back down to the floor or the bottom as it's displayed here on the pictorial to your left. So if you followed photopolymer techniques at all through other players in the space like 3D Systems, EnvisionTEC, Formlabs, and others, what you would learn after a short education is that there's a real challenge in the arena of curing this photopolymer resin and then staging it to its next level or layer. This staging introduces a number of mechanical challenges, commonly referred to as the need for extraction on some sort of tilt system. In common language, you might refer to it as more like pulling off the duct tape. There's a separation that's required to occur no matter what the print material is in question of the day. It really adds a great deal of effort and time to the process of printing these successive hundreds and thousands of layers that make up our complex geometry. So in the case of the Nexa technology, it's a patented and somewhat protected approach that they use to accomplish their goals. But essentially, we have a membrane that's been built of a silicon base with other technologies at work that allow for a sub 1 second. With most materials, we're talking about 0.8 of a second separation to re-engage in the process of printing again. So it's fairly wordy, but I wanted you to understand that a lot of the magic and this outrageous speed advantages we've made has a great deal to do with that membrane. Beneath the membrane, coming up from the bottom photo and working our way up, we also have a very secure, productive light engine that starts with a complex light array, working with a series of pipes and guides, and then projected onto the unique mask that will change on every layer printed. In the case of today's model, 100 microns per iteration. Next slide. So what does that yield? Why the Nexa? Why does this particular Nexa technology and this approach create benefit? And we'll do our best to move a little quicker on a few of these slides now that the core technology is addressed and really speak to what this is. So today, it's a single printer platform, which has a great deal of advantages. We're able to focus on firmware, materials, applications, the user experience, and all of them are targeted to host in this one physical platform. So customers that make this investment are going to realize, upgrades that are releasing again this week, in fact, relative to our firmware and our constant set of improvements that are hitting market. Our number one criteria, of course, is just the flat out speed. We're printing over up to a centimeter a minute, so at 400 thousandths of an inch per minute. And of course, this will be impacted depending on, the print profile, the material you're choosing to print today, and other user options for additional results. But number one, we've got speeds that are 10 to 50x current thresholds in detailed printed throughput. The next is the platform. There's certainly a large menu of printers on market today, but those that are working at our price point and with the finishes and materials provided, we offer a very impressive print envelope to work in. We'll get into the details momentarily, but so you have an understanding, we're talking about an area that is nearly 11 inches by 6.5, 6.25, and a stroke that nearly exceeds 16 inches. So it's a very, very large build envelope. And then of course the quality, our metric set forth by the founder and the engineers on the project were that these were to be injection molded thresholds in terms of surface finish and accuracy that we want to hold onto our parts. So in terms of pausing for a moment, comparing this to other options on market, we are providing a few examples to the left for those of you that are familiar with SLS, DLP, or the 3D Systems SLA technology. But as you can see here, our parts that we're talking about are not coffee cups and ashtrays. These are very, very complex structures with high resolution, supported by less than 3,000ths resolution in the XY. And as I mentioned earlier, While there's an opportunity to print at 50 to 200 micron in layer thickness, most of our recommendations and most of our materials are optimized to run on the equipment at a 100 micron slice height to achieve these speeds. So that will be explored a bit more in some of the following slides. So specifically to drill down on that print envelope, you'll see it through Marios's slide on the window as we speak. I believe he's going to assist us shortly here in kicking off a full build of keyboard keys. If I'm not mistaken, there's nearly 100 units that he'll print while we're conducting the rest of our presentation. And feel free to begin that when you like, Marios. And the envelope he's working in is specifically the 10.8, 6.3, and a 15 3/4 inch stroke in Z. Thanks, Michele. Michele had his mic halted, but he was holding up a sample from a model printed earlier this morning from the same build file. And we'll get a closer look at that later in regards to detail and resolution. So this is no small feat. If we're talking about, for our metric friends, they're a bit more convenient numbers, 160, 400, but you'll routinely see reference made to 19 liters of volume. So while we're giving the machine a few minutes to print, we'll take reference to some of the criteria of the parts. So we've been shipping equipment going back to close of calendar last year, Q4. We have nearly 100 units in the field. Some names I'm sure you're familiar with at Lexmark and Delta Faucet, and Motorola, and Gillette, for example. Very complex geometries, a great deal of detail and precision needed in addition to the speed, the throughput, and the large envelope that we're working with, all coupled to make this a very unique solution. So the part on the left, printed in our gray material, is symptomatic of the type of geometry and output that you're going to see off of the printer. So we'll continue to sort of lean back on the basic 3 to 4 bullets that we think make this a highly unique solution. The approach we've taken to market is that we are going to focus exclusively on the printer, the print drivers, and the applications that clients will use the system for, and that we've offloaded the work on materials development to commercial providers like Henkel, BASF, and others who have tens of thousands of employees in that space and are well suited to provide us with all the material that is necessary. So in doing just that, in focusing on the printer, you'll find that there's industrial grade components used throughout, and that there's a keen focus on automation readiness. And I'll get to exactly why we do that in just a moment. So in addition to the material providers, our focus on the hardware, it would be remiss if we didn't just use one slide to quickly talk about the cognitive software. I'll save it for another presentation and another day. We committed to not take more than 45 minutes of your time. But needless to say, the Nexa 3D organization, while new, is part of the Exponential Works portfolio set of companies backed by venture capital and some significant investment people. And in that effort, one of our sister companies is a software group that is aimed at AI in application for topology optimization. And while I won't go into all the wrinkles and folds and value adds that brings to the table, there's a group of personnel and engineers in shared space with ready access, and we work with that group in the early versions and in the mature versions to come of our software. Early on, basic expected tools such as cameras providing viewing of real-time build, providing users with optimal build profiles in terms of slice height and part orientation are part of the solution. But there are many more pieces of that in play that will be relevant near term. To close the loop just a little bit on that materials discussion, I won't pause long on this slide, but I want to explain why we thought it was so important and advantageous to work with companies like BASF and Henkel. Most of you on the phone in your engineering life, I'm sure you're very well aware that Henkel, for example, is the Procter & Gamble of Germany, and that within this group of companies, a few others we're not mentioning right now, that we have many materials under development and in verification, and we're able to pick and choose amongst those that have a history of performance, strong background, and a real knowledge base in these various disciplines of automotive, consumer goods, or even food and beverage. So we have a fairly impressive and robust half dozen material set today at launch, and many, many more that will be rolling out quarterly. And we'll look at a few of them. Again, here are just a couple of examples of the type of material that are used on the systems. I think rather than go into more details on our suppliers, we'll take a couple of moments and just preview a few of the material specifications. So one of our lowest cost materials, and again, the cost will vary based on our supplier, but these fairly low cost draft materials, for example, really draft implies, when I think about my own 2D printing experience, substandard output. And that is not at all the definition of draft here today. Draft here means that we're supplying a material that's under $100 per kilogram or $40 a pound. And in this draft material, we're generating throughput with the viscosity and color that allow us to drive that printer very, very fast with minimal light exposure per layer. So it results in some of our fastest throughput, but the part when taken off the machine has all the same characteristics of 100 micron printing with great form and fit analysis. It's an attractive color, our early indications and polls tell us, but it's a very low cost, fast way to get parts in hand that are reasonably durable. And here are a few of the specs. It's not as though we would lead with this if the requirement was elongation of break or heat deflection, but you can see it's a robust material. We're not talking about low cost wax or inferior plastics. Stepping up from that, we've got some great materials that are used routinely in automotive applications, like the photo you're seeing to the left. BMWs and others have used this. This is really compelling when it comes down to high precision finishes and textures. So we've had great success with this in printing dashboard models or other details that require a matte finish or high resolution work. And again, by coincidence, the color gray tends to lend itself very nicely to accentuating that and making it visually provocative. Again, the mechanical properties are shared. We have a much more detailed MSDS that we could go into at the right time in small group or one-on-one. And our partners here at Big Systems would be happy to do that with you on an individual basis. Moving a little quicker, we'd like to mention we do have a translucent material. This particular photo doesn't do it as much justice as another model that I perhaps will use in the future, but you get the idea that it's a great material when we're talking about fluid flow models, packaging. I'm not allowed to mention a few of the companies, but there's some household names in food and beverage. They're evaluating this now for onboarding. As with most of these models, there's very little shrink, there's high accuracy, and with just a little, as with all 3D printing applications, if you're looking for glass clarity or water clear, as it's often called, a little bit of polishing is required. And we're very clear and forthright about that, down to minutes, hours, or dollars in terms of what finishing will go into a benchmark so you have clear understanding for your own cost of ownership. Again, this is, it's not a very hygroscopic material, so even though we think about clear in terms of much more the fluid flow or packaging industry, it has proven very, very useful in a variety of surprising fits, if it's shoe wear or other industries where a very water repellent, moisture repellent, yet tough model, upwards in that 5/6 elongation to break, is of service. So it's been a winner. Not particularly an orange fan myself, but it happened to be the flavor it came in. We've got other materials in black with similar MSDS performance specs, but this is really a fairly high heat resistant model at low cost. So fully functional parts, it is of an ABS base. They're strong, but as we take a glance at some of the MSDS, and without going through all the cells and all the digits, I'd call your attention to the HDT is in that 250 Fahrenheit range. And again, if we're all about the heat deflection at high temperature, we can excel that. I'm getting the friendly wave from the home office. So I'll just pause here and ask us to take a look at Marios's thumbnail on the right. Feel free, Marios. I think our build is complete now. So we're just going to pause for a couple of minutes here.
So, take off. All right. Just show you how to remove it. Remove two things here. And then, here they are.
Very nice.
Got a closer view. It's all the keycaps.
Very nice. That's the most I've heard Mario speak in a while. He's got a face for TV and a voice for radio, but we need to pull him out front a little more. But my specs are right. I'm told that's a total of 99 units in 8.5 minutes. So we'll get back to those shortly. Thank you. And we'll send a shipment of those finished parts to Big Systems so they can walk them around with you, along with some more traditional larger parts of a variety of materials, so you have a better feel for the total offering today. This is a material that launched not long ago. They tend to run together. They only get play for 6 or 8 weeks, and then we've got another material behind it. This particular ABS grade is from Henkel, and they lowered the heat deflection for us just a bit, but doubled the elongation at break. So what that means is a very robust single resin part that's exceptionally strong and great in those tough, snap fit, durable ABS-like environments. The specs here, you'd see, as I said, it exceeds the 10% elongation. The heat deflection not as high as the orange. That's where the orange is what we used more for the injection molding applications for short run tools. But again, the communication or the theme is we have a full set of tools in these early days with the first 6 materials and many more coming as it relates to these very fast, highly detailed, accurate parts. So as we wrap up with a couple of slides, and what I'd say, saving a little bit of time for Q&A at the end, is that the general outlook has been one of automation. I've been in the business 20 years, Michele and Avi nearly as long, and we've seen many changes. Often it doesn't happen as quickly as you would like. It's not the software business, for example, where things can change rapidly and in a few quarters or a few years. But here we've got a lot of physical work to be done, hardware, coupling with firmware, integrated with software. But we've all seen great strides with low-end robotics, some highly accurate, fairly inexpensive cobots. And bearing that in mind, we're using everything that we're doing, from the design to the build trays, the durability of the membranes, and you layer that advancement in technology along with the keen single focus of fast, high throughput on Nexa printers, and that all leads us down a path of unattended machine operation in the future. So we're very keen to the whole idea of not only completing a post-process, which every single system has. Very few OEMs talk about it, but they're a part of everything that happens in 3D printing. So using this automation to address either the full turnkey 3D printing experience, and that can easily be translated into what we all see at the automation shows, assembly, packaging, shipping, additional machining operations. So while that's only a handful of years away, that kind of thought process is very much part of how we build the printers and the components in the printers today. So the last slide I have here before I turn it back over to our friends at Big Systems for wrap up is that the manufacturing is done locally here in California. We of course have suppliers all over the world, but the support for our dealer network, the construction, the equipment, spare parts, the management of all of our resin relationships with those global leaders, that's all done here in the States. We've already, in our early successes with our first 100 systems, had successes in the sectors outlined in the middle of your page. And we are ready to expand. So we're having a great deal of fun with this. Those of us that know the space well understand that this really is a jump from dial-up to 5G speeds. And we stand ready to support all of our network with additional benchmark. For those that are serious about considering the technology or adopting it themselves, we have no-cost benchmark services and all the materials previewed here today, and we're able to turn those around rather quickly, given the environment and how our system works. So I'll pause there and turn it back to Ashley or Joe.
Hello, Andy. It's Joe. Can you hear me?
I can.
We have just one question at this point. Hello, Shaku. So this came from our friend Shaku, and he is asking the question about, it's a materials questions. Is Nexa using 1 or 2 part chemistry in the materials?
Thanks. That's a good question. Today, unlike our friends at Carbon, we have not deployed any 2-part resins. It's not to say that it's not possible, but with the results that Henkel and BASF are giving us out of the gate now, and a few that are in verification, we have some very, very tough materials in the 1-part chemistry. I think there are some nice advantages when you invoke the 2-part, but the challenge we run into is the baggage that comes with it. You have a limited amount of working time, and there's no unmixing for the committed vat of resin that you've turned the machine loose with. You need to sort of use it or lose it, and we've got great recapture on anything that we're not able to turn into parts or supports. And so far, knock on wood, we've been able to conquer most of our applications with the 1-part, but it's an area of debate and discussion.
Thank you, Andy. That's the only question we have at the moment. We'll certainly be following up with everybody else on the call to see if we can answer other questions. As I mentioned in my opening comments, Andy is Wisconsin-based. He's got a lot of 3D printing experience, but he's right here in Wisconsin, just right up the road from Milwaukee, and very easily accessible for follow-up conversations or meetings. We're just very excited about this technology for a whole bunch of reasons. It starts with what we think is a very reasonable price point for what you get in this bundle, which includes a much larger build volume than a lot of comparably priced SLA devices that are out in the market. It prints incredibly fast at over 1 centimeter per minute. You just saw a sample build live from California, where they were building over 90 parts in a little under 8.5 minutes. And we can certainly evaluate any type of part or prototype that you may have in terms of letting you know time to print and those other things. It makes a very precise part. We're happy to show samples to you. Extremely fast print times, and we just don't think there's anything else based on all of those things that competes with it out there in the market. And if there are no further questions, we really want to thank you all for joining in on the talk today, and we will be certainly coming back around to follow up with you and see if you have any further questions. So with that, I'd like to just sign off and thank everybody and hope to talk to you soon. Bye-bye.